Hi, Julian here from PopcornFX. In this video I'm going to show you 5 different techniques you can use to spawn particles from specific regions of a mesh. In the effect I have here you can see 3 particle columns emitted from 3 different spots of the mesh. So one way you could do that would be in the game engine to instantiate 3 times a rising particle effect and place them by hand in engine on your mesh and tweak effect properties to change the emission radius particle count for each of the 3 instances. But here I will show you how to do that in a single effect, specially tailored for the mesh and in a way where you can change the mesh at runtime with different versions of the mesh, with some of them having more than 3 emission locations, and have your effect scale seamlessly based on which mesh you pick. So first I will start with an empty effect and create my test rig from scratch as usual. So I'll create a layer, drop a billboard node, set the event multiplier to infinite and to spawn something like 1000 particles per second. We'll reset. And then in the position pin of the billboard renderer, I will drop a spawn on mesh node. Then in the mesh property, I will browse to the mesh I wish to spawn on. And now you can see that all the particles are spawning on the mesh. I will quickly set up a mesh backdrop so I can visualize the mesh itself. And I will pick a texture I painted with some spawn locations which we will use later on. Now this mesh has vertex colors painted in. If you open it in the mesh viewer, however, we don't allow to see vertex colors in the viewport yet. It's something that's planned for the next version for 2.10. But if I open this in Blender and view the vertex colors, you can see it's painted green inside the emission areas, and there is a red gradient on the rest of the mesh. So if I wish to color the particles based on those vertex colors, when I select the spawn on mesh node, in the outputs I can show the color pin, and it's not diffuse color, because the diffuse color would be the diffuse map sampled at the particle locations. The color output pin is the actual vertex color. So if I wire this into my particle color, now I can see the same coloring with the green in the spawn locations and the red gradient. You can see that the particles here disappear. This is because they are additive, so I can't actually visualize black. So I'm going to change the material real quick to opaque billboard, and now I do see my black particles. Quickly going to change the texture as well. Pick a white disk, set the opaque type to masked, so I have an actual disk and it's clipped based on the alpha. And that's pretty much it for the basic sampling. So the first technique is using a simple discard with the vertex color. So this is kind of the classic simple and stupid technique where I just take the color, explode it, explode the 4D vector, and take one of the channels. For example, here I will take the green channel, so that's the Y component, and I will test if it's greater than some threshold. So I can actually use if it's greater than 0. And if it's greater than 0, I will change the life based on that. So I can set a life of 1, and if it's not greater than 0, so if it's 0, I'll keep the life to 0, wire this into the set life. And now I can see that whenever I have vertex colors with a non-zero green component. For some reason, these particles here must have a slightly non-zero green component. I'll quickly increase that threshold. Right. So now it's only spawning inside. I'll increase the threshold some more. Right. So now I have my particles only spawning, well, actually they're spawning everywhere, but the only ones that are kept alive are the ones inside those spawn areas. Another way I could do that would be to keep the set life to 1, and instead of using an if node here, I could use a self.kill, reverse the condition so that it kills the particles when the green component is lower than 0.5. This will do exactly the same thing as using the set life here. It's just another way to write it. So I will insert a physics node and set an initial velocity of, let's say, 3 units up on the up axis. So you can pretty much instantly see here the disadvantage of using the discard technique is that we're actually spawning 1,000 particles per second. They live for 1 second, so here we should have 1,000 particles, like this. But because we are killing most of them, we only end up with around 40 particles. So this makes it both really hard to set an actual precise particle count, and it's also pretty wasteful because, well, you're spawning a whole lot of particles that you instantly kill, and all of them at spawn still have to sample the mesh to get the vertex color to know if they should be killed or not, so it's a bit wasteful. So if I increase the spawn count, I still get the effect I want, but yeah, it's not ideal. So that's the first technique. Also, you will note that I have no way of controlling the density here. So because the area of the mesh in the big column is greater than on the small column, and because I'm using this simple threshold test, there will be a lot more particles in the big column, and I have no real way to control how many particles are spawned in each of these columns. If I wanted the same amount in each of the 3 columns, I have no way to do it with this technique. So fortunately, there is a much cleaner way to do that. So we'll remove this self.kill and revert back to a more reasonable spawn count of 1,000. And now in the mesh input here, I can actually tell it to spawn based on the vertex colors. So I can weight the spawn probability of the particles based on a vertex color channel. So to do that, I will have to create a new shape node, set it to mesh, and I will reset that and use the same mesh. Smoke columns. And with this shape node, I can now change the mesh sampling mode here and switch it from uniform to weighted. So when I pick weighted, I have those 2 properties that I can now change, and it allows me to specify the density color stream and channel. So the density color stream is if you have multiple color channels in your mesh, and the density channel allows you to pick red, green, blue, or alpha. So here I want green, and when I pick green, I now have all the particles which have a non-zero green channel that are generated. Well, particles are generated on the mesh triangles which have a non-zero green channel, to be exact. So this is a much more efficient technique, simply because there is no waste. All particles I spawn, I get them in the end, they are not killed, and I can set exactly the particle count I want, and this is entirely data-driven, artist-driven. You just change the vertex colors and that's it. Your effect updates as expected. However, there is one downside, and it's that I cannot, unlike I did before, I cannot have a base threshold. So here, because I have some vertices with a non-zero green channel, which are on the side here, I still get those red particles. I can't say spawn only on the areas where the green channel is greater than some value. So it will weight the spawn probability of the particles, meaning that fewer particles will spawn on regions where the green channel is low, but some of them will still spawn there. So another technique that's often used is to use a second mesh. So here, instead of using this full mesh, this is kind of a cheating way, I can use another version of that mesh where I only have triangles in those regions where I'm supposed to have particles spawning. So if I open that mesh, it's actually those three areas instead of the entire mesh. This is kind of cheating the thing, but that's also an usual technique to spawn on specific particles. Here I have uniform distribution, so yeah, it's another way to do it. So the fourth technique is similar to the vertex color weighted sampling, and it's to use a density map. So here, if I revert to spawning on the entire mesh and select the spawn on mesh node, you can see at the top here a use density map checkbox. So when I check this, I can pick a texture in the density map property, and I will pick this one. So this texture, on this texture I painted some bright areas on the UV spots that correspond to the internal locations of the columns where I want to spawn. So this technique is quite a bit more expensive than the other ones, but it allows you to do nice things such as controlling the spawn probability based on the how much intensity is painted in the texture. But if you only want to spawn in specific spots without controlling the density, this is a bit overkill. The fifth technique is to use mesh vertices to encode the spawn locations. So it's pretty similar to the third technique that used a specific spawn mesh, except that the only thing we'll have in this mesh is only 3 vertices to say where the 3 spawn locations are. So if I pick this mesh, you can see that there is a single triangle in it, but it doesn't do what we want at all. That's because the spawn on mesh node is trying to spawn on the surface of this mesh by default, but I can switch this to vertex instead of surface, and now we will have our particles spawning on those 3 vertex locations. So you can see that here the vertex colors are also painted with a gradient of red, and we can use that to change the spawn radius. So right now they spawn in a single point, each one of them, but we can change that by offsetting here with a VRAN node. I will quickly reduce the radius. Right, but you see here that well, the 3 columns spawn in a sphere of the similar radius. So if I want to change the radius of those columns, I can use the color. So I will split it with a split vector 4D. I will grab the red component and expose the outer radius and wire the red component in here. So I actually want to remap that. to tweak it a bit better. So I will remap it between from the source value, which is between 0 and 1, and I want the output value to be between, let's say, 0.05 all the way to 0.5, something like that. Yeah, this looks okay, or maybe 0.4. Right. So the sixth and last technique I'm going to show today is a bit different from the others. It's not using any mesh sampling at all. It's actually using the timeline and the timeline keyframe payloads to send over the location data. So when I select a timeline keyframe, I can see it has a time here, but it can also have payloads. So I'm going to create a new timeline track. I could reuse the root one, but I'll just show with a new one that I'll name spawn locations. I have 3 spawn locations, so I will create 3 keyframes. And in the layer graph, when I drag and drop spawn locations and wire it into the event multiplier and reset, so I'll hide the mesh. So here those keyframes will pulse 3 events, and they will in turn generate 3 of those event multipliers, which will spawn 3 columns. Right now they are all in the same location, so I see them as a single column. So the idea here is to add a payload that I'll name spawn location. I will set it as a float 3, add it. And now when I select one of those keyframes, I can see that in addition to the time, I have that spawn location. So I'll set the first one to be 1 in the X direction, the other one to be 0.5 on Z, and the last one to be 1.5 on Y. So here when I reset, the columns are all at the same place because spawn locations isn't any kind of special payload. So I need to do something to extract that value and use it to offset the spawn locations. So when I go inside this layer, if I drop a event payload extract node, and in the payload name I pick spawn location, this will output the float 3 that I've specified in each of those keyframes. So here I'll just wire it here. And you can see now that as soon as I do that, I pick up the values I've set up in the timeline. So I'll show the mesh again, and I will add a local position to world node because previously the spawn on mesh node was taking care of transforms, but here if I spawn the effect at multiple locations, well, everything will keep spawning at the origin, so I need to transform that to world space, and now I have the proper transforms. I can check the follow instances checkbox of the mesh backdrop so that whenever I spawn an instance, the backdrop follows. So quickly, I will update the spawn locations payload to spawn in the correct location. So one thing you can see is that because those keyframes have different times, they will start spawning whenever the time cursor hits them. And if you want them to spawn all at the beginning, that's kind of a limitation of this technique. It's that you can't really, well, you could set them on the exact same time, but then you wouldn't be able to select them in the UI. So you might be tempted to move them all before time 0, but when a keyframe is below time 0, it doesn't get spawned at all. So you will need them to be above time 0 to be taken into account. So one pretty cheap thing you can do is just zoom in and just place them very close to each other so that it's not noticeable. But yeah, it's pretty tedious to do that. So similarly to the position, I can also add a new payload for the spawn size and adjust the vrand radius based on that, and have each column behave differently. So this last one is probably the most limited of all 6 techniques. I wouldn't advise in using it most of the time, especially since you can't expose that to the game engine, so it will be basically hard-coded inside your effect. Whereas all the other techniques that use a mesh node, you can expose the mesh node as an attribute and change the mesh in the game engine. So that's it for this video. I hope it was useful. See you next time and have a nice day.